we have already discussed regarding dot convention and basics of network. Now, dot convention, it is used for the magnetic circuit, and the first lecture we will discuss regarding basics of circuit and network subject. Now, any problem related with this two topic? जिसको समझ नहीं आ रहा है कुछ भी इसमें, or you got all the points? हेलो संभળાય છે?
Yes, sir.
हाँ એટલે
सभी समझ में
मैं
आ गया.
हाँ ठीक है ना, तो आई ऑलरेडी डिस्कस 2 पॉइंट्स. जिसको भी समझ नहीं आ रहा है यू जस्ट टेल मी, so I can explain again if you are not getting the point, because it is most important all points as far as the examination is concerned. So we'll discuss fundamentally, thoroughly, all points I have to discuss first of all. Now today we'll discuss with one important point, that is duality. Now we know that in circuit and network we have some topic which is very easy to solve the problem. But once you don't know how to solve the problem, then you cannot solve this problem, because it is very simple to solve, but you have to have basic fundamental of that topic. So what at present at today's lecture I am discussing regarding the duality of the network. We already discussed the basics of fundamental of circuit and network. Then we already discussed the dot convention, how to put the dot, how to write the equation, and we have 3-4 types of varieties of example that may be asked in the examination. Now today we'll discuss with a very simple and very easy topic, that is the duality. Now we know that in our electrical engineering we have a different types of circuits. Now you might be knowing, we have to solve the circuit with the help of certain theorems. That the basic theorems that we all are familiar with, that Norton's theorem and Thevenin theorem. This basic is mass analysis and node analysis. Then after, there are other theorems are also there to solve any complicated network. So we know that in Thevenin and Norton, this mash and node network or mash and node method, both are, we can say that this mass analysis, it is used with the help of with the connection with this Kirchhoff's voltage law. That is more mass analysis or loop analysis. In that case, we have to use Kirchhoff's voltage law, right? Now in case of node analysis, we have to use Kirchhoff's current law. That is very simple thing. But in our syllabus, that node and mesh analysis also you have studied in first year. Some fundamental you are knowing how to solve this. But in our as far as the third semester is concerned, we have another topic that is included, that dependent source. Means we have to solve our problem with the help of depending source. So depending source, that depends upon either voltage or depends upon current. So we know that we have 3 types of voltage source. One voltage source, that is that one is voltage source, one source is voltage source, one is current source. Both are, it may be constant. Suppose I am saying that it is 5 volt DC. So that is the DC voltage source. If I say it is AC 5 volt, then it is a alternating supply. Or if it depends upon some parameter, that suppose some voltage source depends upon current passes to the other branches, that we already discussed. There are 4 types of dependent source, that voltage dependent source, current dependent source. In voltage dependent source, we have voltage dependent voltage source, current dependent voltage source, And in current source also we have two types of current source. That is the current dependent current source and voltage dependent current source. So today we'll discuss that is all regarding mesh and node analysis that we'll discuss in next lecture. But today's lecture we will discuss with a very fundamental point, that is duality. Now the question may arise, what is duality and why it is required? That is my first question that is in your mind. Why this duality is required and what is duality? What do you mean by dual? Dual means two, right? If we say both are dual, dual means two. That is the very simple meaning of that dual. Now duality is a system. So I'm just sharing a presentation that is very easy to understand. Just a minute. Huh? I have to close all other. Right. Hello, is it visible?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So today we'll start with the duality. Now the word says duality. At that time, just was taking a tool for explain. Now, what do you mean by duality? Right. That duality, it is something related with the similarity. If I say both are similar, similar, just like a similar, or there are two words, that is similar, similar and ideal. Sorry, ideal. Now similar is the word in which the sum of the components means the format of the equation is same. Now ideal means both are exactly similar, exactly equal, you mean to say. As for example, suppose first of all I have to explain the basics of duality. Now we know that we have several analogous situations in the network. Like for example, if we use Kirchhoff's voltage law, then we have to use Kirchhoff's voltage law with the mesh analysis or loop analysis. We know that in loop analysis we cannot use Kirchhoff's current law, because current law it is used for parallel circuit. Something like some Kirchhoff's current law can be used in node analysis. If we use node voltage, if we want to find out node voltages, then we have to use Kirchhoff's current law. If we want to find out the mesh current or node current, loop current, then we have to use the Kirchhoff's voltage law. Same way, in some case, likewise, some of the equation, that is intro differential equation, means integration and differential combination of that equation, that some equations that results from two Kirchhoff's voltage law are similar in appearance. This is one important word, that is similar in appearance. Suppose I am writing equation in mass analysis using Kirchhoff's voltage law. I am writing one equation. Then after I have to write the Kirchhoff's current law equation. And if I observe that both equation, you can appear, you can if you visualize both equation, that will be same in the format, in appearance. દેખાવમાં એકદમ સરખા લાગશે તમને equation. રાઈટ, ખાલી શું પ્રશ્ન હશે એની અંદર દેખાવની અંદર કે એના જે પેરામીટર છે એ something is different, something is different. So some results we are obtaining from Kirchhoff's law to Kirchhoff's law, that is Kirchhoff's voltage law and current law. Now this repeatedly similarly as only a part of large pattern of identical behavior pattern in the role played by the voltage and current in the network analysis. So I'm just explaining this sentence with the help of some equations. Now the similarity with all the implications or suggestions is termed as principle of the duality. That means similarity between two equation as far as the pattern is concerned. Pattern એટલે શું કહેવાય ને? Pattern એટલે style. That is a style. In that pattern, if the pattern is same, then we can say this both equations or both circuits are dual of each other. Principle of duality means the similarity with all the implications or suggestions is termed as the principle of duality. Like just I'm doing one I'm taking one example. Suppose we have a circuit like this VT, a very simple circuit, RLC circuit in series, RLC series like R, L and C, right? And other that is the loop analysis. Now the same circuit I have to if I draw in this fashion in parallel, I have to use Kirchhoff's current law, right? So I have to write the equation, say VT is equal to R into I. Suppose current passes through, we have already assumed the direction of current, so I into R. So that is I into R, voltage across. Means the Kirchhoff's voltage law says that total voltage is equal to voltage drop across the circuit. Right, so this is Ri. What is the voltage equation in inductor? That we already discussed, that L di by dt. And what is the voltage across in capacitor? Because we know that capacitor has current value. So IC is equal to, that also already I have given in our first lecture, that IC is given by C dV by dt. C dV by dt. That current in inductor. So if I want to find out the value of V, equation in terms of V, then I have to integrate this equation. So this equation is known as intro differential equation. Right. Now if I write the equation for loop analysis, using loop analysis for this circuit. Right. So that circuit is like this. Suppose say the value is R dash, L dash and C dash. So I have to write the equation, say here I have to find out current in all branch. What is Kirchhoff's current law says that this current is equal to summation of this current. So current I is equal to I1, I2 and I3, summation of I1, I2 and I3. Current in resistance, this branch which is given by I1. So I1 is equal to this voltage V1, V dash with respect to ground. Because we know that this voltage, this point and this point, the voltage is V dash. So it is with respect to ground. This is the ground terminal. Okay, we have to take one terminal as a ground terminal. Now this equation, you can write the equation in this way. First, that V dash upon R dash, 1 upon R is equal to Z. We have written here one parameter G. Then after inductor current is an integration equation, because it is I. Suppose you want to find out current equation in terms of I, so that integration of 1 upon L integration integration V dt. That is current in inductor. This is current I2, and this is I3 current in capacitor. That is C dV by dt. Now I have write these two equations. You can observe these two equations are same in the pattern or the format. Here we can observe the differentiation. Here is also differentiation. Here is no differentiation, simple. Then here is also integration. Here is integration. That means these two equations are same in format, not in value. I'm talking about you have to clear this point, that I'm not saying that both are the value is same. I'm saying that the format is same. So if I put L, if I put C dash instead of L, C dash, whatever the value of L, same value I have put as a C. Whatever value of R, I have put this value as a G. Whatever the value of C, I am putting this value as a C. C is equal to L dash. So this this integrate differentiation with differentiation, simple with simple, integration with integration, and here current voltage with current, right? So you can observe from this equation, then both equation are formatted in the same way. Formatted in the same way means we have a differentiation without differentiation and integration. In second equation also we have voltage differentiation, then simple equation, and then integration. The parameter is different. Here is I, here is V. Here is I, here is V. Here is I, here is V. And here L, C dash, R, G dash. And 1 upon C, 1 upon L. That means the parameter, this is the, what is this? This is the constants. This constant is different, but the format is same. So if we replace this L with C dash, R with G dash, and 1 upon C with L dash, and I with V, I with V dash, I with V dash, I with V dash, and I with V dash, then we will get the second equation, and V with I. So if we can put this equation in this manner, and the pattern or the format of the equation are same, then we can say that both equation are a dual network. Dual network. Now why it is required? Because in some time, what happens, sometime this loop circuit is somewhat complicated. So you can convert this loop circuit into a node circuit of that dual network. That dual network, you can convert this same. If you are finding the current in all these branches, or if you find the response of the circuit, suppose we want to find out voltage across R in this circuit, then we have I into R, this is the voltage across this resistance. Here also you can calculate V dash, this is the across R. So this R and these both are same. That means if we change the circuit configuration, the response remains the same. That means both are dual network, dual network. But the parameter is something different. I am just taking one simple example. Say, if we have, I am taking one simple example. If we have similar hobbies, हमारी आप में से किसी दो स्टूडेंट्स का जो हॉबीज है वो सपोज सेम है, ठीक है. सपोज बोथ आर एंजॉइंग प्लेइंग गेम्स ऑन द कंप्यूटर. देखो ना, दोनों प्लेइंग गेम कर रहे हैं. सपोज पबजी खेल रहे हैं, एक पबजी खेल रहा है, एक दूसरी कोई गेम खेल रहा है, right? But both are enjoying the game, but it may happen that one is playing PUBG and other is playing another game. That means this different game which is equal to the parameters, right? अगर मुझे इन दोनों को ड्यूअल दिखाना है, दो स्टूडेंट्स है, स्टूडेंट्स 1 एंड स्टूडेंट 2, if I say both are dual in that sense, both having hobbies for playing game on computer, enjoying the game in computer. That is the format of the equation. ठीक है ना. अभी फॉर्मेट में दो अलग भी हो सकता है, इसका पबजी हो रहा है, इसका पबजी भी हो सकता है, इसका कोई और गेम हो रहा है, लेकिन both are enjoying the game with the computer. That enjoying the game with the computer is a format. So I can say both are dual in terms of enjoying the game in computer. Suppose that means this 1 and 2 are dual with each other. That means the hobbies are different, hobbies are same, but the game they are playing both are different. So here is also, you can observe this equation. Now in this equation we have the format is same. Format means hobbies same, but the parameter R and G is different, C and L is different, L and C is different, right? So that parameter, if I replace this hobbies, suppose this game 1, that is G1 and G2. Suppose I want to draw a dual circuit of this one, then what I have to do is, because we know that the same is hobbies, the hobby enjoying the game, which game doesn't matter. So if I replace this G1 with G2, G1 with G2, then I can say that this circuit or this second circuit is a dual of first circuit. Or if I replace G2 by G1, then also I can say this is the dual circuit of 1, dual circuit of 2, and 1 means 1 is the dual circuit of 2. So in that way, the one important point that if we replace this L value, suppose L value is 2 Henry, and what is C unit is Farad, so we can replace this 2 Henry with 2 Farad. Simple, 2 Farad. R is suppose 2 ohm, so we can replace this G dash by 2 ohm. Now the question is that G is equal to 1 upon R. That is your question, that how can we put this R is equal to G? But I am not putting the exact value. I am not putting this PUBG here. Here is PUBG, here is other game, COD suppose. So I can say that this G1 is G2. The format is the game. Format is game. Which game I don't bother. So here is also I want parameter G dash. G dash, suppose I replace with R with G dash, then we can say that this is the dual network of the first network. So value you have to replace as it is with the unit change. I'm just taking the example also. So in this way, suppose I'm just taking one more example that is very simple example. Okay, okay. Now in this equation, the format is same, so I can replace some parameter. If I replace the parameter, this parameter is known as dual quantities. Like here, I have this. Okay. Now from equation 1 and 2, that is the previous equation we have discussed. Now in that case, you can replace Ri with Vg. You can see here Ri with Vg or Gv. Okay, then di by dt with dv by dt, integration of I dt with integration of v dt, voltage with I dash, voltage with current, inductor with capacitor, and C with L, inductor with capacitor, capacitor with inductor. If you replace this value, then we have this is known as analogous value. These all are analogous quantities. If we 1 and 2 equation we compare, this replace with this, L di by dt replace with C dv by dt. The following are the pair of dual quantities. Suppose we want to create a dual network, then we have to use this pair. So R is replaced by G or G is replaced by R, simple. Whatever the value you have to put as it is. Now L is replaced by C, C is replaced by L. Loop current is replaced by node voltage. Here I already given this equation. So this is loop voltage that will be given by the loop current, that we have replaced this loop voltage and loop current, because we know that Kirchhoff's voltage law used for this mass analysis and Kirchhoff's current law used for the node analysis. Okay, now this Q charge can be replaced by psi, that is rate of change of flux. Integration of this current, that is the integration of voltage, that already we have find out. Loop, that will be changed by the node. Short circuit, that will be changed by the open circuit, and current source, that will be taken as a voltage source. So these are the pair of dual quantity that you have to remember. So you can remember these things with the help of this value. Then we can say that this value are replaced. Now how can we suppose this is a very simple example. The parameter, if you are not changing, nothing will happen. I already told that the response remains the same, right? Suppose we have a voltage equation like 2 volt, 2 ohm and 2 ampere, 2 ohm is connected as a load, and suppose we want to find out IL. So how can we find IL is equal to 0.5? 0.5. If I have a circuit, replace the circuit of this, that equal to I suppose 1, 2 by 2. I'm just putting this 2 as it is. 2 I'm putting here as it is. So what is here is 1 ampere, here is 2 ampere, here is 2 ohm and 2 ohm. So what is current in this branch again? 0.5. So this is 0.5, this is also 0.5. That means response remains the same if we if you make a dual network. So this B circuit is known as dual of A. Now the how we have to create a dual network. It is very simple method. So that I will show one by one. You have to note down the steps also, that these steps are given in any network book you just referred. So that dual network, you can say that in first step, suppose we have the circuit like this, and we want to find out dual network of this circuit, dual network of this circuit if you want to find out, right? So the first step, that you have to put node inside each loop, place a node and give its number for all loops. Suppose we have 1, 2. How many loops we have? 2. One loop and second loop. So I put one dot here. That is first dot. I have given the name 1. Second dot I am given the name 2. Now you have to go clockwise direction. You can also go anti-clockwise. It doesn't matter. But I am just taking one standard method. So that, and third node you have to take outside the network. So we have three node, 1, 2 and 3. That first node you have to take as in first loop, second node in second loop, third node in third loop, right? So that, and third node means is not third loop, that is in outside, that is known as reference node or datum node, that is known as reference node, reference node or datum node. So this is first step. You have to put all dots. How many? Suppose we have 4 loops or 5 loops, that you have to put all 1, 2 and 1 out. That is first step is completed. Now the second step, place this same number of node on the separate space on the paper. आपको क्या करना है, और एक पेपर पे ये डॉट जैसे हमने यहाँ पे रखे हैं 1, 2 and 3, you put as it is 1, 2 and 3 on blank paper, right? So I'm just I have to draw both circuit in the same. Okay, now here, right? That 1, 2 and 0, 1, 2 and 0. Okay. So now third step. This is second. First step you put the dot. Second step you put the dot outside. जिसको जहाँ पे हमको ये dual network अभी बनाना है, ठीक है? Now the third step. Now in figure 1, draw a line between two nodes of the original network, traversing only one element at a time. That is very important. So now figure 1 means this. I'm just removing this all lines. तो आपको क्या करना है, फ्रॉम दिस नोड, जो कॉमन नोड है उस पर पहले आपको लाइन ड्रॉ करनी है. सपोज वी हैव a common node between 1 and 2. So I have joined 1 and 2 because each node, each elements, you have to travel once, दो टाइम, 2 times आप वहां से नहीं ट्रैवल कर सकते, आपको एक ही बार जाना है, ठीक है? That 1 and 2 in between, 1 and 2, you have to connect this 1 and 2. So in 1 and 2, what is resistance is connected? So what is our dual analogy quantity with the resistance? Resistance की जगह पे क्या रखना है हमको? G रखना है. That G. So G means same as resistance 1 upon R. You can say that G, that is conductance. So वही रखना है. तो 1 के बीच में मैं रख रहा हूँ ये this. That is G. 1 and 2. I have written G. Okay. Now second case. In second, सो दैट अगर और कोई है ही नहीं, दो दो सेकेंड नोड से थर्ड नोड पे भी नहीं जाना है, ठीक है ना। अभी क्या करना है, ईच एलिमेंट्स को डेटम से कनेक्ट करना है, रेफरेंस से कनेक्ट करना है। सपोज आई एम कनेक्टिंग वन दिस वन नोड, लाइक आई एम स्टार्टिंग फ्रॉम हियर, इसको यहाँ से अंदर जाना है और यहाँ कनेक्ट करना है, ठीक है ना। यहाँ पे क्या आएगा अभी, because here I'm putting this polarity like this, so instead of voltage source we have the current source, because it is given that current source with voltage source with current source. So that current source यहाँ पे रखना है आपको, that current source, what is the direction of current source, like negative to positive, that will be negative to positive, that यहाँ से आपको connect करना है उसको, right. Now in second case here, that means the current source I have to put from 1 to datum, तो 1 से start करना है मुझे, यहाँ से I have put one current source, ठीक है, then after, oh sorry, okay, this यहाँ पे connect समझ लेना आप, मैं connect नहीं कर सकता, okay, I'm starting from here, I am connecting, like this is current source having the direction like this, that is known as, instead of V I have to write I, that is current source like this. इसको पहले आपको ऐसे ही ड्रॉ करना है, बाद में ये वाला बनाना है। Then after what I have to do is I have to connect this circuit with, now second, अभी कौन सा बाकी पैरामीटर है, ये कैपेसिटर, तो यहाँ से मैंने स्टार्ट किया, या यहाँ से स्टार्ट किया मैंने, इसको कनेक्ट किया यहाँ पे मुझे क्या रखना है, what I have to put here, instead of capacitor I have to put inductor, ठीक है ना। तो 1 to 0 अगेन वन मोर टर्मिनल, that one, sorry, that 1 to inductor, and I have to connect this like this, sorry, this is not proper inductor, I have to connect it, okay, that means, okay, so what is this, instead of C it is L, sorry, instead of C it is L, right. Now another case R. So what I have to do is I have to one more time I have to travel through this 1 2 1 2 with resistance only, that is G, and connect to this point. This point I have to connect this with this, यहाँ पर connect करना है आपको इसके साथ, right. This one node I have to connect this way. That means इसको यहाँ से पास करना है, उसके अंदर से जाके you have to put this. Now from 1 to datum node again one more resistance. So what I have to do is I have to connect one more resistance here. से यहाँ से start करेंगे हम लोग, इसको यहाँ से कहाँ कनेक्ट करना है, like this, here I have to connect. So this is G, this is G. So this is also one terminal. To 1 to datum there are 3 parameters, 1 2 and 3 parameter, and 1 between 1 and 2. Now the same we have to repeat with this, here I have to put the polarity like this, ठीक है ना. So that will be say starts from 2, it starts from 2, यहाँ से जाना है आपको, you connect with this datum 1, that will be connected with resistance. So I have to put 2 to datum, that is one more resistance, that is G. 1. Suppose this is G1, this is G2. Because it is R1 and R2. sorry, it is R3 na, so it is G3. G3 here, sorry. Okay. This is G3. I have to connect again. And this is G3. Right, this is G1, this is G2, and this is G3. Now what is another case? Same, that is current source I have to replace with the current voltage source with the current source. This is the voltage source which यहाँ से start करना है आपको 2 से. Then I have to connect like this. तो अभी ये one more current source I have to connect. Like say one more current source. The direction is upward direction because it is minus to plus. So that I2, you can say this is I2, this is I1. Right. So this is one more current source. Now one more 2. It is connected with datum. So I have to write here one this inductor which is connected to datum with capacitor. So I have to replace L with capacitor. So one more resistance, one more point I have to connect here. That is capacitor. This is a capacitor, not supply. It is a capacitor. So this will be, so it is connected resistance like this. This is resistance, capacitor, sorry. So this will be replaced, this L will be replaced by C and C will be replaced by, means we have how many component we have? 1, 2, 3, 4, 5, 6, 7. So here is also 1, 2, 3, 4, 5, 6, 7. So this is a complete dual circuit of the above circuit. So I have drawn here again like this. So whatever the method I have followed. So yeah, this is the third step. अभी अब ट्रैवल करना है तो वी हैव ट्रैवल फ्रॉम दिस ऑल, तो उसको पहले ऐसा रफ सर्किट बना देना है. देन आफ्टर यू हैव टू पुट अ डॉट, उसको डॉट पे कनेक्ट करना है, डॉट पे कनेक्ट कर लो. देन आफ्टर यू विल फाइंड all parameters. Whenever all parameters should be covered, it should be covered all parameters. तो कर लिया इसको. तभी देखो मैंने दिस सेम डॉटेड लाइन से कनेक्ट किया और जो पैरामीटर चेंज करना है दैट आई हैव रिटन हियर इज करंट सोर्स और इंडक्टर और कैपेसिटर दैट, एंड उसको बाद में आई हैव ड्रॉन हियर दिस इज अ डॉट and I have finally I have connected the circuit as we have connected here. This is the circuit like this. Okay, so in this way you can connect a dual network. Suppose a second example, suppose we are taking here. This is if we draw a dual network of the shown figure like this. So we have 3 loops here. So what is first step? You have to put a dot 1, 2 and 3. Right, now we have to put 3 dots here again. Right, so then after we have to put a point where we have to connect a dot. Suppose this is 1, 2, 3. So I put 1 dot here, 1 dot, here is 3, here is 2 suppose. So 1, 3, 2. You can put 1 2 3 also, but you have to draw the circuit which looks good. ठीक है ना, अच्छा ये वाला अगर ड्रॉ किया तो कोई प्रॉब्लम नहीं है, दैट विल बी ओके, बट वी हैव टू connect the circuit in this way. So somebody like to see that systematic circuit, like, so 1 and 3 now, this is datum, that is 0, that is 0. So between 1 and 2, sorry, 1 and 2 we have the capacitor. Instead of capacitor, what I have to connect? Inductor. So I am connecting inductor here between 1 and 2, right? So instead of this capacitor, I have connect inductor. Now between 1 and 3, 1 and 3, what is this? Resistance. So I have to connect 1 and 3 in between. Resistance in between. So that resistance also I have to connect, right? That resistance I have to connect like this. Between 1 and 2. This is 1, this is 2, this is resistance. Now 3 and 4, inductor. Instead of inductor, I have to read capacitor here. So I am connecting one more capacitor between 1 and, sorry, between 2 and 3. 2 and 3. वो हो गया अभी कॉमन वाला हो गया. Then after I have to write 1 से कितने connected है? 1 is current source. So I have to connect one current source. Instead of voltage, I have to connect one current source here. One current source having direction, upward direction. That depends upon the direction of your voltage source. So that will be upward direction. You can put upward direction inside. यहाँ पे दिखाना है आपको अंदर, ठीक है ना. That current direction I already shown here. अभी क्या करना है आपको? 1 2, और कोई है ही नहीं पैरामीटर इसमें. देखो एक पैरामीटर कॉमन, दो कॉमन है और एक यहाँ पे हो गए 3 पैरामीटर, 1 2 3. देन आफ्टर फ्रॉम 2, ओके, 2 नो 2 से कितने पैरामीटर है? एक ही आउट जा रहा है, रेजिस्टेंस. बाकी ये दो तो कॉमन है. तो वन रेजिस्टेंस आई हैव टू कनेक्ट फ्रॉम दिस सर्किट, दैट इज फ्रॉम डायटम. आई हैव टू कनेक्ट लाइक resistance with this. This is R. This R. I have replaced this R with this R. 2 to 0. That 2 to 0. Then after 3 से कितना जा रहा है? 1 capacitor with replaced by the inductor. तो 3 से अभी क्या करना है? यहाँ पे लग रहा है 3 to datum. 3 to datum means यहाँ से start करना है. You have to write here. Instead of capacitor we have inductor here. इसको कनेक्ट करना है यहाँ पे. तो इधर सर्किट ये ज्वाइंट है पूरा, अभी ज्वाइंट नहीं हो रहा है, मतलब ये ज्वाइंट है. तो you can see that here also I have put one dot, that 1 2 and 3 I have put here. Same circuit मैंने बनाया, nothing is different, but I have put this in systematic way. So जैसे डॉट आप रख रहे हो यहाँ पे, उसी हिसाब से यहाँ पे डॉट रखो 1 2 3, राइट. तो दैट इज द मेन सर्किट. सो दिस इज द ड्यूअल नेटवर्क. सिंपल, वेरी सिंपल. आपको यू कैन पुट योर ड्यूअल नेटवर्क इन दिस सिंपल मैनर. यू हैव टू रिमेंबर ऑल स्टेप्स. फर्स्ट ऑफ ऑल डॉट रखना है आपको. देन आफ्टर यू हैव टू पुट डॉट ऑन प्लेन पीस पेपर. और यहाँ से पूरा अभी आप ऐसे रफली फिगर ड्रॉ कर लो पहले. तो वही फिगर को फिर रिप्रोड्यूस करना है यहाँ पे. 1 2 0, 1 2 2, 2 2 3, देन 3 2 0, 2 2 0 एंड 1 2 0. तो दैट वी हैव टू ड्रॉ द सर्किट. तो देखो मैंने इसको रीअरेंज किया पूरा. तो दैट विल बी द सेम सर्किट आई हैव ड्रॉन हियर. ठीक है ना. दिस इज द सर्किट पूरा बनाया, अभी चेंज किया. नाउ द नेक्स्ट इज, दिस इज अ सर्किट. This is something more complicated network, that we have 1 2, 3 and 4 loops. 4 loops. Right. So you have one node, two node, three node and four. You can give node as per your convenience. आपको जैसे भी देना है आप दे सकते हो, ऊपर नीचे इसको 1 दो उसको 4 दो, that doesn't make any difference. Means we have to put a dot in such a way that it covers all loop 1 2 3 4. ठीक है ना. अभी क्या कर रहा है, एक datum node बाहर रख लिया हमने, that datum node we have put here. Now 1 to 2, first of all you have to covered all common components, 1 to 2, then 2 to 3, then 3 to 4, 3 to 4, then 3 to 4 and 2 to 4, that you have to cover. Then after आपको क्या करना है, this all parameters उसको यहाँ से अभी actually ये यहाँ से आना चाहिए, that is something यहाँ से, ये वाला नहीं, that is not that, like that. Okay, अभी देखो, you can see here we have one common 1 to 2, but we have three parameters, that 1, 2 and 3. This parameter capacitor replaced with the inductor, this resistance replaced with the resistance, inductor replaced with the inductor. The value, whatever the value, that suppose 1 ohm resistor, that 1 ohm 1 Henry inductor, you have to replace with 1 farad. Now the question is, why sir we have to replace this? Because I already explained that we don't have to put exact value, we are simulating. Similar means we are changing the formats. तो फॉर्मेट में क्या है, इंडक्टर की जगह पे कैपेसिटर है, मतलब वॉट एवर द वैल्यू ऑफ इंडक्टर यू टू प्ले पुट द सेम वैल्यू एज अ कैपेसिटर. 1F that is 1 farad, that 0.1 Henry that is 0.1 farad, 2 farad that is point, सपोज ये वाला इंडक्टर जा रहा है, ये इंडक्टर ये कैपेसिटर बनेगा पूरा ये वाला, so that inductor value is also 2 Henry. If you replace in this way, then we can say that both are the dual network. So we can say that here 1 node, 2 node, 4 वाला बीच में आ रहा है, तो हम लोग बीच में रखा है 4 and this is third, right. अभी 1 से कितना जा रहा है, 1 2 and 3 पैरामीटर्स. तो देखो 1 से ग्राउंड में कितना जा रहा है, डेटम में 3 पैरामीटर्स, 1 is inductor, 1 is resistance, 1 is capacitor, right. We have replaced 1 ohm with 1 mho. We have replaced 1 Henry with 1 F, and we have replaced 1 Henry 1 farad with the 1 Henry. Simple value आपको रखना है, अभी इसका कोई एनालिसिस आगे नहीं करना. You don't have to find any current passes through branch or all. We have to make only the dual network, which shows that if we write the equation of this figure with this value, and if we write the equation of this figure with its value using mass analysis and using node analysis, we will get the same format equation and we will get the same response. Then we can say this network is dual network, right. So this is the second procedure that we have to find out. In this way you can find out the dual network. So the dual network is a network which shows exact format, same format. इसका सर्किट का जो फॉर्मेट रहेगा इक्वेशन का, that will be same as this, provided we have to change the parameters, like whatever we have this parameter change, like L with respect to L से क्या रखना है, ये जो पैरामीटर मैंने बताया ना आपको, this are the pair of dual quantity that you should have to remember. ठीक है ना, इसको आगे आपको करना है तो that you should have to remember this dual network, dual pair, dual quantities. Okay, so as far as this dual, there are a number of examples also there, and I want to give one tutorial that based on this dual network, right. तो आपको क्या करना है, वो ट्यूटोरियल सॉल्व करना है जब भी आपका टर्न रहेगा ट्यूटोरियल, that in some batch with me and some batch with the NN Sastra. So what you do is you have to solve the tutorial with given time limit. और अब क्या करना है, we have already given 3 tutorial, so you have to write the tutorial on the piece of paper, convert this into PDF, then upload in your class only. Whatever tutorial we have uploaded, you have to go turn in आपको टर्न इन करना है जैसे हम लोग गूगल क्लास में करते हैं, और आपको वो ट्यूटोरियल इसमें अपलोड करना है, ठीक है ना। तो माई रिक्वेस्ट इज टू ऑल स्टूडेंट्स दैट यू हैव टू सॉल्व द प्रॉब्लम विथ योर ऑन। कहीं से कॉपी मत करो, आप करोगे तो मुझे पता नहीं चलेगा वैसे तो, लेकिन आप कॉपी मत करो। यू हैव टू सॉल्व द प्रॉब्लम because whenever I'm putting the marks of viva, I'm asking some questions, so you are unable to give the answer to that question. I know that you have solved this problem with your own, otherwise if you copied this, so it is not possible to give the answer, right? So for that, for getting maximum mark, you have to you have to solve the tutorial in time एंड सॉल्व द ट्यूटोरियल विथ योर सेल्फ। तो क्या करोगे आप, ये जो पूरा आपको एक नोट बन जाएगा, सो दैट नोट विल बी यूजफुल बिकॉज वॉट एवर ट्यूटोरियल आई हैव टेकन, दैट इज ट्यूटोरियल may ask in examination of GTU, or it is already asked in examination of GTU paper, question paper। तो अगर उसमें पूछा है वही मैंने लिया है, और बहुत सारे सम्स ऐसे हैं, so that I have taken that is important questions that may be asked in examination, right? So this is a very simple method to solve any dual network. Suppose we have a dual network like this. There are another example is also there, that is somewhat complicated network. This is a network complication network. One more, okay, now one more important point, that the limitations of the dual network. What are the limitations of dual network? That dual network cannot be it is not possible for non-planar circuits. Non-planar circuit means the circuit which is overlapping each other, like you can see here. So you cannot clarify the mass analysis, you cannot put, because it is the not dual network. It is not possible because ये देखो यहाँ पे ओवरराइड कर रहा है, इसको यहाँ पे ये ओवरराइड कर रहा है, ये ओवरराइड कर रहा है, बट अब इट इज अ नॉन प्लेनर सर्किट। सिंगल एक पीस पे आप ड्रॉ कर सकते हो प्लेनर सर्किट, तो दैट इज ऑल्सो, सपोज ये वाला सर्किट है, ठीक है ना, ये वाला सर्किट, तो ये ड्यूअल है कि नहीं है? यू जस्ट टेल मी, इट इज ड्यूअल नेटवर्क इज पॉसिबल और नॉट? को भी बचा देख के बताओ मुझे।
No.
No, sir.
No.
Why?
वो ओवरलैप
नहीं सुन,
प्लेनर नहीं है ना सर, वो
हैं?
ओवरलैप हो रहा है, ओवरलैप
लेकिन
होता है ना, और रजिस्टर और इंडक्टर।
अच्छा, आई एम जस्ट ड्राइंग द सर्किट, रीअरेंजिंग द सर्किट, ओके। अगर इसे रीअरेंज कर सकता हूँ ऐसे, लाइक दिस, ओके, दिस इज वन सेकेंड, this is inductor, and this is again inductor, like, now this circuit I can put like this also. Is it okay? Right, I am resistance, whatever the resistance I am writing, that also I am putting here, or in other word it is same, it is as it is यहाँ पे रख रहा हूँ मैं रेजिस्टेंस को, ठीक है ना। अभी इसको हम लोग निकाल रहे हैं, सॉरी ये क्या निकल गया अभी, इसको हम लोग यहाँ पे आई एम जस्ट राइटिंग द सेम रेजिस्टेंस। मैंने क्या किया, ये ब्रांच को पकड़ के बाहर ले गया मैं, ये वाला, ठीक है ना। अभी ये जो ब्रांच मैंने यहाँ पे दिखाया हुआ है, between this and this point, I am writing here, I can draw the figure like this. Is it okay? ये हो गया। अभी ये मैंने ये वाला वैल्यू को ऐसे पकड़ के ऊपर ले गया मैं यहाँ पे, अब कनेक्ट कर ही सकता हूँ ना मैं, ये मैंने आपको कंफ्यूज करने के लिए आई हैव ड्रॉन दिस फिगर। तो व्हेन यू रीअरेंज दिस सर्किट, सो देयर इज नो ओवरलैपिंग हियर, फर्स्ट लूप, second loop, third loop, fourth loop, there are 4 loops are also available, so dual is possible in that case, right? So such type of circuit is given, all this such type of circuit is, you cannot say it is non-planar circuit। आपको क्या करना है, उसको रीअरेंज करके देखना पड़ेगा। इसको आप रीअरेंज नहीं कर सकते हो बिकॉज इट इज नॉट कनेक्टेड लाइक दिस। यहाँ पे ओवरलैपिंग आएगा ही आएगा, बट इसमें ओवरलैपिंग नहीं है, तो इट मे बी आस्क इन शॉर्ट क्वेश्चंस. जो मैं एग्जाम लेने वाला हूँ सैटरडे को, नेक्स्ट सैटरडे वी हैव प्लान वन एग्जाम दैट बेस्ड ऑन द एमसीक्यूज, इज अ पार्ट ऑफ आवर स्टडी जो मैंने करवाया है, वट एवर आई हैव लर्न to you. So you have to give that examination on Saturday. I will share the schedule also. Right. तो ये वाला जो है, ऐसे भी आप पूछ सकते हैं एग्जाम में आपको कि भाई ये है कि नहीं है, जैसे सबने बताया नहीं है, बट इट इज पॉसिबल. इसका पॉसिबल नहीं है, आपको क्या करना है, यू हैव टू फाइंड आउट, यू हैव टू ड्रॉ रीअरेंज द सर्किट. आपको रीअरेंज करना है, अगर हो रहा है तो ठीक है, अदरवाइज नहीं है. ठीक है ना. सपोज दिस इज अ वेरी कॉम्प्लिकेटेड सर्किट, 1 2 3 4, तो कितने सारे पैरामीटर्स हैं, उसको हम बनाएंगे, ऐसा बन जाएगा. उसको रीअरेंज भी कर सकते हो आप अपने हिसाब से. आई पुट 1 2 3 4 लाइक दिस, 1 2 3 4, जैसे मैंने यहाँ पे लिया है वैसे ही मैंने ले लिया है यहाँ पे डॉट, और सब पैरामीटर्स यहाँ पे लगा लो आप. देन यू कैन फाइंड आउट द वैल्यू. राइट. सो दीज ऑल रिगार्डिंग द duality of the network. राइट. सो इज इट्स ओके, इज इट ओके, समझ पड़ गया ना पूरा आपको ये, यू गॉट द पॉइंट. हेलो.
Yes, sir.
ओके.
Yes,
तो
sir.
अभी
Yes, sir.
आपको क्या करना है, वॉट एवर द ट्यूटोरियल आई हैव फ्रेम, आई विल शेयर द ट्यूटोरियल टू योर बैच. तो आपको वो ट्यूटोरियल सॉल्व करना है. मेरे बैच में जो बच्चे हैं उसको वही ट्यूटोरियल सॉल्व करना है, दूसरी बैच में जो बच्चे रहेंगे वो को अपने जो ट्यूटोरियल के सर जो है वो दैट विल शेयर दैट ट्यूटोरियल. ओके. सो विद दिस वी कंप्लीट करते हैं अपना इस सेशन. राइट. सो आई एम जस्ट टेकिंग attendance, please don't leave.